Today we're focusing on Module 4, Lesson 3, and we're building tape diagrams to generalize once again, but this time with addition and multiplication identities. So the first lesson was all about addition and subtraction identities. We said things like 2 plus 3 minus 3 equals 2. And then yesterday, or rather Tuesday, we talked about multiplication and division. So we said something more like 2 times 3 divided by 3 equals 2. But we've talked about how addition and subtraction kind of undo each other, and multiplication and division kind of undo each other, and we end up back where we start each time. Today's quite different. Today we're still generalizing, which remember, at this point, hopefully you've got that in your brain. Generalizing means to figure out addition and multiplication identities. So we're going to discover the link between these two. Before it's been kind of undoing things, now we're going to see how these two can be linked together, multiplication and addition. So let's start here. My goal is for you to try to write two different expressions for each picture you see with tape diagrams. So here's our tape diagram. So let's first think of a multiplication expression and an addition expression. Well, I see 3, 3, and 3. So that's 3 groups of 3. So it makes me think 3 times 3. What does it also make me think? Well, it makes me think that's a total of 9. I can also find that by doing 3 plus 3 plus 3. So I can also think that as 3 plus 3 plus 3. So look how those two already might be kind of similar. See if you can come up with 2 expressions here for B, 2 expressions for C. See if you can do that in about 1 minute. Pause the video and come right back. So hopefully you've paused the video, you've given this a shot. Please, please, please make sure you try it on your own first before you just watch me do it. Because if you watch me do it, you're not going to learn it as well as you normally could. So let's try this. Okay, well I see 2 different things here. I see 1, 2, 3, 4, 5, 6, 7, 8. I see 2 8s. So that makes me think this could be 2 times 8. But that could also mean 8 times 2, however you want to put it. But we have 2 groups of 8. So you could have also had or 8 times 2. Let's think for the addition expression. Well, it looks like we're adding 8 plus 8. We're not adding 2's repeatedly. So if you add 2 plus 2 plus 2 8 times, that's not what we're doing. We're taking an 8 and adding it to another 8. So the group size can help you think about what numbers to use. Let's look at our next one. Oh, for this next one, how many groups do we have? It looks like we have 1, 2, 3, 4, 5. And we have 3 of those, so I could think of it as 5 plus this 5 plus this 5. I don't want to do 3 5 times because I don't see groups of 3. So what does this mean here? This means 3 times 5 or 5 times 3, however you want to think of it. So this is where our daily lesson kind of gets started, our 3G and G equivalent. Prove your answer using a tape diagram. Well, this is kind of weird, 3G. Well, this right here, we'll learn this a little later in the module, but this right here means 3 times whatever G is. Remember, G is a variable. It stands for some number that we do not yet know. So let's think about this. Prove your answer using tape diagram. Let's set up a tape diagram model and try to start to explain this. So I'm going to put my tape diagrams over here on the left. And then we can label it with an expression on the right. And the expression kind of, if this is the picture in the book, these are the words explaining what's happening in the picture, if you've been kind of stuck on that this week. So let's think about this. 3G and G plus G plus G. Let's think about how we show G plus G plus G. Well, if it's anything like what we did up here, 3 plus 3 plus 3, we know with the variable, I can start with, here's G. I can label it G. Let's go ahead and put another one in there. G and G. So right here, this shows G plus G plus G. But what does it also show us? Well, let's actually put all these together and call it what it is. We also say that this represents, well, G, G, and G. All of that is equal to 3G. So this is worth 3G. So the statement we're trying to make here, we can see they're the same thing. The picture doesn't change from here to here. So I can say G plus G plus G, that is equal to, that is the same thing as 3G. So let's say I gave you 4y. What would you say 4y is equal to? Well, look at kind of the pattern we're starting to see here. The 4 tells me 4 times y. Well, that means I have y plus y plus y plus y. Let's try another one. Let's just make up a couple. Let's try this. What if I said you had x plus n, sorry about that, we'll focus up here, plus n plus n. What would that equal? Well, we have two x's, so I'm going to say 2x plus 2 n's. So 2 x's and 2 n's. Let's go ahead and keep going here. Hopefully you're starting to get the hang of how multiplication and addition are related in this world of expressions and equations we're talking about. Let's go ahead and skip to number 2 in the group growth plan. Number 2. So number 2, you have these 3 problems right here. And I want you to work on these 3 while I add in a few other problems over to the right. So I want you to write an equivalent expression to demonstrate the relationship of multiplication and addition. So here, tell me what 6 plus 6. How could you show me that using multiplication, just like we did on the other page? So here I might say 2 times 6, or 6 times 2. You work on B and C while I write some more examples. Okay, well, let's look at B and C here. Hopefully my camera will focus up there. I see 3 times 3 times 3 times 3. No, sorry, not times. 3 plus 3 plus 3 plus 3 plus 3 plus 3. It's 3 added together 6 times. We know a short way to do that. Instead of just adding it, we could do 6 times 3. You might have had 3 times 6 as well. That means the same thing. That's going to equal the same thing. All right, let's look at this next one. What can I say this is equal to? Well, let's see. 1, 2, 3, 4, 5. If I'm repeatedly adding something, that means adding it over and over and over again, means I can just multiply it instead. So this means 5 times 4, or 4 times 5, however you want to think of it. All right, so here's 2 more examples for you. Both of them involve variables. This one, we already see addition. I want you to shorten it using multiplication. This one, this means 3 times z. This means 2 times x. I want you to expand it. So try those 2, pause it, come back and see how you did. All right, so with this first one, we have 2 m's. So that means 2m, 2 times m. We've got 3 a's, or 3 times a. Now, the 2 sets are being added, the a's and the m's are being added together. So here's what I'm going to say what this is equal to. I'm going to say it's equal to 2m plus 3a, because 2 times m means the same thing as m plus m. 3 times a means the same thing as a plus a plus a. Let's look at this one. First, let's focus on expanding it. So 3 times z, in addition land, that's the same thing. I can think of it as, well, that's the same thing as z plus z plus z. So let's start our expression with that. Z plus z plus z. And then let's think of 2x. How does 2x expand? Well, that means 2 times x. That means x plus x. X plus x. So let's just tack that on to the end here. Plus x plus x. So hopefully you kind of got the hang of this. We'll move on to our next station in just a second.